Hello everyone, welcome to today's session. Okay, I hope there are no audio and video issues. So, all right, we are going on to the second lecture of CSAT for UPSC CSE, and not just for UPSC. This can be useful for almost all kinds of examinations, competitive examinations, because quantitative aptitude is something that is common for literally every exam that you write. Okay, competitive exam that you write. Even for applying jobs in private companies, the campus selection and all, even during those times, CSAT is very important. All right. So there will be a series of lectures on CSAT. There are many subtopics under this. So today we are going to see operations on numbers. All right. There will be two lessons on operations on numbers. Today is the first one, and one more lecture will be there on Monday. Okay. 2 days will be taken to cover this section. So today I'm going to introduce you to this topic and give you some very simple questions to start with, and then gradually we will increase the difficulty, and in the second lecture, pretty competitive exam level questions will be done. Even today we will be doing similar things. Okay, so I am Madhav Sankar Warrier. Welcome to Madhav Sankar classes. If you are new to my channel, please do subscribe to this channel and share it with your friends also, so that they can also benefit from all these lectures. So CSAT, operations on numbers. Okay, this is part 1 of operations on numbers. So before beginning, let me just remind you, in the previous lecture, there was one question in which the methodology I used was slightly wrong. I had mentioned it in the comment section and in my Telegram channel. So I will be doing that question also today, but towards the end of this lecture. Why? Because that question deals with whatever I'm going to be teaching you today. Okay, so good evening, Seema. Welcome. So I hope you all have a paper and a pen with your hand in your hand, because all these are mathematical things and you have to solve out each of these things. Okay, so introduction. So basically we are going to start with what is a number and what are the different types of numbers and all these things, because these are very fundamental. Clear? These fundamentals has to be 100% clear in order for you to do a question as such. These are very simple things. You will already know all these things. But just in case, okay, I'm just mentioning it for those who are, not thorough with the basics. So basically, a number is denoted by a group of digits, right? A group of digits together forms a number, right? And in our Hindu Arabic system, we have 10 digits, 10 different digits, 0, 1, 2, 3, all the way up to 9. So two common terms that we see regarding numbers is face value and place value. This is important for your exam. Okay, face value and place value. Place value is sometimes known as local value as well. So what is this place value and what is this face value? Let's take an example. Okay, say consider the number 167. All right. So what is the face value of 7 in this number? What is the face value? Face value is 7 only. What is the face value of 6 in 167? Face value of 6 is 6 only. And face value of 1 is 1 only. Clear? So the exact value of that digit is known as the face value. Whatever is seen, that's it. We are not going to add the place value to it. So face value means literally that the value of that digit, that's it, nothing more. Now, place value, okay, place value, or also known as local value. So let's take the same number, 167. So what is the place value of 7 in 167? Place value is 7 into 1, that is 7. Units digit. You all know that, right? In a number, say if there is a number like, say, again, 167, then 7 is in the unit digit place, 6 is in the tens place, 1 is in the hundreds place, and so on, like 1000, 10,000, 1 lakh, and it goes on like that. I think you are very familiar with that. So place value of 7 is 7 only. So 7 into 1. Place value of 6 is what? 6 is in the tens place. So 6 into 10 is 60. Similarly, place value of 1 will be 1 is located in the 100th position, right? 100th place. So 1 into 100. So that would be 100. Clear? This is the difference between face value and place value. Place value carries that weight also. Okay, the weight of that position. Face value means simply that digit. That's it. One interesting thing is that when, as for 0, okay, whenever that digit is 0, the face value and place value will be 0 only. So just take an example. I'm writing another number, 286. Say, let's take another one, 2803. In this, we know that the value of 3 is 3 only, both face and place. Place value of 0 would be actually 0 into 10. But that is 0 only, right? So this is a unique property of 0. Both place value and face value of 0 in any number would be 0 only. Clear? So I hope you understood the difference between what is a face value and what is a place value. Oh, these are simple things. I'm going to move on. Now we are going to see some types of numbers. Okay, what are the different types of numbers? And because these are also important in the connection with the series and all. In the next class, we will be studying about arithmetic progression, geometric progression, and things like that. So you have to know what are the different types of numbers. Natural numbers, first one. Something very common, we all know that. So what are natural numbers? Natural numbers are those counting numbers starting from 1 all the way to any number that we can count. It goes on to infinity. Alright, all the positive counting values comes under natural numbers. Positive counting values. So 1, 2, 3, whole digits. Okay, you can't say 1.1, 1.2, no. Only the whole values, only the complete digits, counting numbers. Okay. Second one is whole numbers. What is this whole number? Whole number is same as natural number, except 0 is also there. Okay, if you add 0 along with natural numbers, you will get whole numbers. Understood? These are entirely different. I mean, you might think that why would we give a new name to this entire set by simply adding 1 0 to it? But this has huge implications in mathematics that we do not have to look into today. But just understand that natural numbers along with 0 forms the whole numbers. Now integers. What are integers? Integers means all the counting numbers, both negative, 0 and positive. Okay, natural numbers does not have negatives in them. Clear? Whole numbers does not have negatives in them. But in integers, we also add negative. So negative 1, negative 2, negative 3, minus 4, minus 5, all these positive values also, and 0. So the entire thing together forms a set of integers. I hope you understood the difference between all these things. Very, very important. Okay, now we have even numbers. I think these are very simple, so I'm going to go through it very quickly. Even numbers are those numbers which are divisible by 2. Then we have odd numbers which are not divisible by 2. And then we have something called prime numbers. Correct? This is very important. Okay, prime numbers are important for us. So what are prime numbers? Again, this is a very, very very low standard thing, you might think, because we have studied this in like 5th or 6th standard, or even in an earlier time. Correct? So prime numbers are those numbers which have exactly 2 factors, 1 and that number itself. For example, let me take this number 13. 13 is the prime number, correct? Why? Because 13 has only 2 factors, 1 and 13. That's it. 8. Is 8 a prime number? No. Why? Because the factors of 8 are 1, 2, 4 and 8. Factors means what? Those numbers which can divide the set number. Those are known as factors. So 8 has multiple factors. 8 has more than 2 factors. So 8 is not a prime number. But 13, another example, 11. 11 has only 2 factors, 1 and 11. So those numbers which have exactly 2 factors are known as prime numbers. So these are very similar. I mean, we might think that why should we focus on all these things? The thing is, as long as these numbers are very small, we can, at least we can logically think and work out if that number is a prime number or not. But what happens when the number becomes bigger and bigger. In the exam, if a number above 100 is given, and if you are asked to check if that number is prime or not, how would you do it? Would you sit in the examination hall and check the divisibility of every single number before that? No, right? We need to have some kind of a method to check if that number is a prime number or not. A quicker method that saves a lot of time. Correct? So there is a test to check whether a number is a prime number or not. Clear? Good evening, Raju. Good evening, Nandini. If you have any queries, please feel free to ask. However simple it is, I will be glad to explain it once again. Okay, so what is the test to check whether a number is prime or not? Let's take a number. Let that number be P. Okay, let P be the given number. And let n be the smallest counting number such that n square is greater than or equal to P. Don't worry, I will explain it using an example. At that time, you will understand it way better. Alright, now what we do is, we check whether P is divisible by any of the prime numbers less than or equal to n. If yes, then P is not a prime number, otherwise P is a prime number. Very confusing. Now let me give you an example. Alright, so take a number 173. If this number is given in your examination, and if you are asked to check if it is a prime or not, I mean they won't ask the question like that. Maybe the question will be which among the following numbers given is a prime number, and you will be given 4 options like 173, 200 and something, 300, 480 something. Okay, you will be sitting in the examination hall and wasting a lot of time if you don't know this method. Clear? So how would we check? The given number is 173. So once P is equal to 173. So according to this rule, what are we supposed to do? We have to find a number n. And what is this number n? It is the smallest counting number such that n square is greater than or equal to P. So the square of that number should be greater than or equal to P, and it should be the closest one. Okay, so what is our n here? N, we are going to take n as 14. Why? Because the square of 14 is 196, which is greater than 173 and closest to 173. Right? I mean, if we take it as 13, the square of 13 is 169. 169 is not greater than 173. According to the rule, n square should be greater than or equal to P. So if n is 14, n square is 196, which is greater than or equal to 173. Correct? So our n is 14. Understood? Now what we do? We go to the second step. We have to check whether P is divisible by any of the prime numbers less than or equal to n. Okay, now so which means we have to see if 173 is divisible by any prime number less than n. So n is 14. So what are the prime numbers less than 14? 2, 3, 5, 7, 11 and 13. Correct? Prime numbers less than 14. We can, I mean, this thing we know. We know the prime numbers less than 100 very easily, very quickly we know which are they. So here n is only 14. So we have to write down the prime numbers less than 14 and see if 173 is divisible by any of these numbers. I will teach you an easier way to do divisibility in the coming slides. But for now, let's check. 173, is it divisible by 2? No, 173 is an odd number, so definitely no. Is it divisible by 3? There is a test for divisibility of 3. I will tell you later. But anyway, 173 is not divisible by 3. 5, no. 7, no. 11, no. 13 also no. So coming to step 3, if yes, P is not a prime, else P is a prime. So here nothing is divisible. So 173 is a prime number. Did you understand that? Is it difficult? I will give you one more example so that you can easily understand it. Okay, one second. Let me just clear this. Okay, I will give you another example. 437. This is the question. Check whether this number is a prime number or not. Okay, let's see. What is the first step? We have to identify P and N. So given number is P. Okay, so P is equal to 437. Our first thing is to find the value for N such that N square is greater than or equal to P. So we need to find a value for N such that N square is greater than or equal to P. So I recommend that all of you study the squares of natural numbers from 1 to 25 minimum. Okay, from 1 to 25, please by heart the squares of natural numbers. This will make things very, very easier for you during examination. Okay, because if you know the squares of these numbers by heart, you can easily say that 20 square is 400, 21 square is 441, which is greater than or equal to 437, correct? So the N we are looking for is what? 21. Clear? So we have identified N. So that is first step. In the second step, what do? We have to write down the prime numbers less than 21. Prime numbers less than N. So what are they? 2, 3, 5, 7, 11, 13, 17, and 19. Correct? Did I miss anything? 2, 3, 5, 7, 11, 13, 17, 19. No. Okay, these are the prime numbers less than 21. Now we have to check whether 437 is divisible by any of these numbers. And I mean, you can check it yourself, but actually 437 is divisible by 19. Okay, 437 is perfectly divisible by 19, and therefore 437 is not a prime number. You can check it, okay? 437 divided by 19. We can do it here. 437 divided by 19 is 2 19s are 38, and we have 5 and 57. So 3 19s are 57, and it is perfectly divisible. So it is not a prime number. I hope it's very clear now. Any questions? Okay, Bharat. Yeah, environment classes will be there. In the upcoming days, I will be taking environment and CSAT in a mixed fashion. I told you. Alternatively, we will do that, but in the previous class, I only gave you an introduction. So today it has been CSAT. So next class will be environment. After that, again CSAT, and it will be we go on like that. Okay, I will try to keep up that alternatively, but sometimes I will have to combine two environments or two CSATs according to whatever I can make of it. Okay, but both will be completed before December 31st. I do not plan to extend the class beyond that. Okay, so I will wrap up everything before January. So the entire portion for both these will be completed by December 31st. Okay. Anyway, I hope you understood what a prime number is, and I hope you understood how to check whether a number is a prime number or not. All right, moving on. So we were talking about the types of numbers. Okay, even number, odd number, prime number, and then we have composite numbers. What are composite numbers? Those numbers which are not prime are known as composite numbers. Okay, I think that you already know. Those numbers that are not prime are known as composite numbers. Okay, now we have coprimes. Very, very important. Again, what is a coprime? What are coprimes? Two natural numbers a and b are said to be coprimes if their HCF is 1. Okay, in the next chapter, okay, not in the next session, but after that, I will be taking a topic called HCF and LCM. Okay, highest common factor and the least common multiple. Very, very important again for your examination. At that time, I will explain this concept much better. But for now, let's take the word for it. Okay, so coprimes are two natural numbers such that their HCF is 1. HCF means highest common factor. Let's consider an example. Okay, 4 and 5. What are the factors of 4? Factors of 4 are 1, 2 and 4. Correct. Factors means the number which can divide the said number. So 1, 2 and 4 are the factors of 4. What are the factors of 5? They are 1 and 5. If you look at them, the common number is on 1 only. There is no other common numbers. So what does that mean? The highest common factor is 1. And two numbers having the HCF as 1 are coprimes. The examples include 2 and 3, 4 and 5, 7 and 9. Very, very important. Look at here. 4 is not a prime number, but 4 and 5 are coprimes. Similarly, 9 is not a prime number, but 7 and 9 are coprimes. Clear? Don't confuse it. Very, very important. Now comes the main topic for today. Test for divisibility. Okay. Even in this year's exam, CSAT exam, there has been questions regarding this. Not just CSAT exam, also IBPS, SSC exams. Similarly, all such examinations, we come across questions on divisibility. Not direct questions, but I will show you some examples. So we have to check the divisibility of a number all the way starting from 1 up to 11. Okay, we are going to study only up to 11. That is enough. More than that is not much important. So how do we know if a number is divisible by 2? What is the test of divisibility by 2? Very simple, right? If it is an even number, it is divisible by 2. Otherwise, it is not. Very simple. So if the unit digit place is 0, 2, 4, 6, 8, or any of these, then that number is even number. So that number is divisible by 2. Very simple. You all know that. Next comes divisibility by 3. How to check whether a given number is divisible by 3? What we have to do is, we have to find out the sum of digits and see if the sum is divisible by 3. That's it. I will give you an example. Okay, consider this number 7944330. You have to check whether this number is divisible by 3. In UPSC, they won't ask it like that. They would ask, what should be added or subtracted from this number in order to make it divisible by 3. Okay, the question will be like this. Okay, that more it will be something indirect. So we will be doing some problems in that regard as well towards the end of this session. Okay, but for now, in order to do that, we have to know this. Clear? These are the basics. So 794430, is this number divisible by 3 or not? If we do not know the procedure to check a divisibility of 3, what would we do? We would do the division and we will see if there is any remainder. If there is no remainder, it is divisible by 3, otherwise it is not. But that will take a very long time, especially if the number is too long. So according to this procedure, we have to find the sum of digits. So sum of digits means 7 plus 9 plus 4 plus 4 plus 3 plus 0. What is this? 7 plus 9, 16 plus 4, 20 plus 4, 24 plus 3, 27 plus 0 is 27. Is 27 divisible by 3? Yes. Correct? You know that 27 is divisible by 3. So this number is divisible by 3. Understood? Add the digits together and see if the sum is divisible by 3. If it is, then the set number is divisible by 3. Got it? Another example. Say 864223. Is this number divisible by 3? Let's check. 8 plus 6 plus 4 plus 2 plus 2 plus 3. What is this? 8 plus 4, 16 plus 4, 20 plus 2, 22 plus 2, 24 plus 3 is, sorry, I think I'm 18, 20, 25, sorry. Okay, then value is 25 when you add all these things. Correct? Is 25 divisible by 3? No. So the set number is also not divisible by 3. This is how you calculate whether a number is divisible by 3. Find out the sum and check if the sum is divisible by 3. Okay, moving on. Divisibility of 9. Divisibility by 9, sorry. Same procedure, add the digits and see if the sum is divisible by 9. That's it. Very simple. Exactly same as that of 3. Okay, let's do an example. 8, 1, 7, 2. This is the given number. You have to identify if this number is divisible by 9. So what do? You add all these numbers. 8 plus 1 plus 7 plus 2 is what? 8 plus 1, 9 plus 7 is 16 plus 2 is 18. And 18 is divisible by 9. So this number is also divisible by 9. Got it? Another example. 6, 4, 3, 2, 7. 6 plus 4 plus 3 plus 2 plus 7 equal to what? 10 plus 3, 13 plus 2, 15 plus 7 is 22. 22 is not divisible by 9 and therefore this number is also not divisible by 9. I hope you understood. I am taking it very slow. I am explaining all the processes. I am writing even the addition of all these things so that everyone of all levels, okay, but maybe you are all geniuses in maths, okay, but everyone may not be so. That is why I am not skipping any steps. Clear? So yeah, this number is not divisible by 9. Moving on. So these are the easier ones. Now this is divisibility by 6. How do you do this? In order to check whether a number is divisible by 6 or not, all you have to do is check if that number is divisible by 2 and 3. That's it. Okay, check if that number is divisible by both 2 and 3. If it is, then the given number is divisible by 6. Otherwise, it's not. Let's take an example. Okay, 216. Is this number divisible by 6? I mean, we all know that it is divisible by 6 because 216 is the cube of 6. 6 into 6 into 6. But let's check. Is it divisible by 2? Yes, because it is an even number. So it is divisible by 2. Now, whether this is divisible by 3. How do we check for divisibility of 3? Add the given digits and see if the sum is divisible by 3. So 2 plus 1 plus 6 is 9. And 9 is divisible by 3. So this number is divisible both by 2 and 3. Therefore, it is divisible by 6. Clear? Another number, 519. Is it divisible by 6? No, because it is not divisible by 2. Another example, 722. Is this divisible by 6? It is an even number, so it is divisible by 2. But is it divisible by 3? Sum is 7 plus 2 plus 2. That is 11. 11 is not divisible by 3. So this number is not divisible by 6. Are you getting it? Did you get the point here? Okay, so very simple. Again, same method, very easy. Moving on. Divisibility by 4. Okay, divisibility by 4. In order to check whether a number is divisible by 4 or not, what you have to do is check if the last 2 digits, the number formed by the last 2 digits is divisible by 4. That's it. Okay, now let's take an example. Consider this number 7976636. So either we can divide this number by 4 and completely divide it, takes a long time, and see if the remainder is 0. And then if it is 0, it is divisible by 4. That is the lengthier method. What is the easy method? That would take time, right? The lengthier method, although we can easily arrive at the answer, it takes a lot of time. And time is very important for CSAT and all these examinations. So we have to arrive at the answer as quickly as possible. So the last 2 digits, 3 and 6, together forms 36. Is 36 divisible by 4? Yes, right? 9 fours are 36. So 36 is divisible by 4. Therefore, this number is divisible by 4. See, very easy, right? Just think about it. Rather than dividing this entire number by 4, which takes at least a minute, all you have to do is look into the last 2 digits, the number formed by the last 2 digits. If it is divisible by 4, the entire number is divisible by 4. Otherwise, it is not. That's it. whatever the number is. Okay, the number can be a 100-digit number. All we need is to check the last couple of digits. Okay, another example. Say 812946. You have to tell me whether this number is divisible by 4. Tell me, 812946. Is this number divisible by 4? No, right? Yeah, Nandini, correct. Why? Because 46, the number formed by the last two digits, 46, is not divisible by 4. So this number is not divisible by 4. Got it? These are the easier methods. So if you know all these simple techniques, UPSC, CSAT would be nothing for you. Correct? It saves a lot of time. You can crack literally any exam, bank exam, IPPS, whatever, RRB. And next, so moving on. Divisibility by 8. Same process, except we have to take the last 3 digits. That's it. Okay, while analyzing the divisibility of 4, we took the last 2 digits and checked whether that number is divisible by 4. But in this one, to check the divisibility of 8, we take the last 3 digits and see if that is divisible by 8. Let's take an example. Okay, so 6874352, a long number. If you are going to divide this, it takes some time. So what are we going to do? We are going to do the easier method. We are going to take the number formed by the last 3 digits, that is 352. And now we are going to see if this number is divisible by 8. That doesn't take much time, right? Dividing a 3-digit number, that doesn't take time. So 352 divided by 8 is what? 4 8s are 32. Again 3 balance and 2 comes down. 4 8s are 32. So there is no remainder, which means that is divisible, right? 352 is divisible by 8. So this entire number 6874352 is divisible by 8. Understood? Another question for you. You have to do this. 637356. Find out whether this one is divisible by 8. 637356. Is it divisible? All you have to check is the last 3 digits, the number formed by the last 3 digits. So 356. Is 356 divisible by 8? No. Okay. So this entire number is not divisible by 8. Clear? Up till here, I hope everything is clear. Divisibility by 2, 3, 9, 6, 4 and 8. Now 10 and 5, the easiest of them all. How would we check if a number is divisible by 10? Just see if that number ends with 0. Right now, if any number ends with 0, then that number is divisible by 10. Correct? It doesn't matter how big that number is. If it ends with 0, it is divisible by 10. Otherwise, it's not. What is the divisibility test for 5? If that number ends with 5 or 0, it is divisible by 5. Otherwise, it's not. Right? 65. Right? 135. 790. All these are divisible by 5 because it either ends with 0 or it ends with 5. So these two are no-brainers. Everybody knows it. So these are the easiest ones. Now the difficult ones. Divisibility by 7 and then divisibility by 11. These two are a bit tricky. Okay, and as for 7, it is better you divide it anyway. Okay, I mean, if a question comes like that, I suggest you divide it because this technique itself is not that much efficient. I mean, it gives you the answer, but it doesn't save too much time anyway. But I will tell you the technique just for your understanding, and maybe this would be easier for you. I don't know. The test is this. You have to find the difference between twice the unit digit of the given number and the remaining part of the given number, such that that difference should be a multiple of 7 or it should be equal to 0. I know that you did not understand anything, so I'm going to explain with an example. Okay, divisibility test for 7. Let's take an example. 798. Is this number divisible by 7? Easiest way, you just divide it. Okay, just see if there is a remainder after dividing it. So, this is, I would recommend this division only. Divide it by 7. 1 7s are 7, nothing. 9. 1 7s are 7, remaining is 2 and 28. So 4 7s are 28. It is perfectly divisible because it is remainder is 0. You can do this. Okay, but just to give you an understanding of this method, how would we do this? Take the units digit. Unit digit is 8. Multiply it by 2. So 8 into 2 is what? 16. Correct? And then what we do? We subtract this one from the remaining number. Remaining number means 7, this one, 79. So 79 minus 16 is equal to what? 63. Correct? And we have to check if 63 is divisible by 7. If it is divisible by 7, then that number itself is divisible by 7. Otherwise, it's not. Here 63 is perfectly divisible, right? 9 7s are 63. And because it is divisible, 798 is divisible by 7. Understood? Let me give you another example. 119. How do we check? First, we take the units digit, 9, and multiply it by 2. So 9 into 2 is 18. And then take the remaining number, 11 minus 18 gives you minus 7. Forget the sign, okay? Negative, positive doesn't matter. Is this divisible by 7? Yes, 7 by 7 is 1. So perfectly divisible. So 119 is also divisible by 7. Clear? Another one. 449. Is this divisible? How would we do it? Take the units digit and multiply it by 2. So 9 into 2 is 18. And now subtract this from the remaining number. 44 minus 18 is what? 44 minus 20 is 24, plus 2 is 26. So is 26 divisible by 7? No. And therefore 449 is also not divisible by 7. I hope you understood the method. This is how you check for divisibility of 7. Okay. And now to the last one, divisibility of 11. Divisibility by 11. Again, slightly complicated, but it is worth it because this is something that is seen in most examinations, especially for bank and all. Okay, questions based on divisibility by 11. Very, very important. In order to check whether a number is divisible by 11 or not, what we do is the following. Okay, so a number is said to be divisible by 11 if the difference between the sum of its digits at odd places and the sum of its digits at even places is either 0 or a number divisible by 11. Right now it sounds Greek and Latin, don't worry. I am going to explain it again using some examples. Okay, so given number 29435,417. Check whether this number is divisible by 11 or not. So what we do is we have to find the digits in the odd places and find the digits in the even places. All right. So let's first find the digits in odd places. So from right, okay, you have to take it from right. So 7, 4, 3 and 9. So 7 plus 4 plus 3 plus 9. Okay. Minus sum of the digits in the even places, that is 1, 5, 4 and 2. So 1 plus 5 plus 4 plus 2. All right. So what is this? This is equal to the sum of this one is 23 minus, and this the sum of this is 1 plus 5, 6 plus 4, 10 plus 2, 12. This is equal to 11. Correct? And 11 is divisible by 11. So this number is also said to be divisible by 11. Understood? When you are given a number, first of all, add the digits in the odd places and subtract that with the sum of the digits in even places. And if the answer is either 0 or divisible by 11, then the set number is also divisible by 11. All right. Now another example, 5, 9, 6, 3, 8, 9, 7. Is this number divisible by 11? Let's check. What are the digits in the odd places? 7, 8, 6, and 5. So 7 plus 8 plus 6 plus 5 minus digits in the even places, 9, 3, and 9. So 9 plus 3 plus 9 is equal to 7 plus 8 is 15 plus 6 is 21 plus 5 is 26 minus 9 plus 3 plus 9 is 21 is equal to 5. Is 5 divisible by 11? No. So this number is also not divisible by 11. I hope you understood the process. Most questions that come in the examination are from this area. Divisibility by 11. Very, very important. Okay, I hope you understood the method. Now let's move on into something, the questions and all. Okay, but I would also recommend you to study these formulas. I'm not going to go through each and every one of them. All these formulas are something that you have already studied in the school. Algebraic formulas. You can easily download a chart of this from internet. Literally any website, all mathematical websites have all these things. So get a printout of all these formulas, paste it in your wall or something, and go through them. At least these ones. There are plenty more than these, but these are the basic ones, fundamental ones that everyone should know. Okay, so study all this. A square minus b square is a minus b plus a into a plus b the whole square, a square plus 2ab plus b square. So these are things that we have studied in our younger classes. So please do go through these formulas and by heart them so that things would be much, much easier for you. Okay, now let's start with some questions. First question for the day, based on what we have studied so far. Okay, these questions are based on number theory. I taught you about divisibility and all. Some questions are simple, multiplications and all. These kinds of questions come in SSC, even in UPSC sometimes. Okay, mostly seen in SSC examinations, central government examinations. 986 into 307 minus 986 into 207. This is the question. Okay, I'm going to start the timer. Please see if you can solve this in the given time. Hello Kushbu, welcome. Okay, Nandini got most of the answers correct. Very good, Nandini. If any of you have any questions or if you want me to explain anything once again, feel free to put it in the live chat. I will do that. Okay. If I am fast or something, if you want me to slow down a bit, I hope it's clear. Okay. So give me the answer to this question. 986 into 307 minus 986 into 207. Tough question, right? Think about this, multiplying everything and then subtracting it and then finding out the answer. Come on. Who can give me the answer quickest? Be intelligent, guys. Okay, be intelligent. Don't jump into 20 seconds to go. So probably on Monday, I will take environment. Okay, but I think we will complete number theory first. Okay, so Monday I will do this one only, CSAT only, and then Tuesday. Okay, I won't be able to take class on Wednesday, so I'm going to prepone that to Tuesday. Tuesday I will take environment. Okay, Monday CSAT second part of this chapter, and on Tuesday environment and ecology first chapter. All right. So nobody gave me the answer so far. So I will explain how to do this. A novice student would probably multiply this first and then multiply this and then subtract that and that, and will take a lot of time. And the aspirants near you would do 3 questions by the time you finish this. But an intelligent candidate, what would he do? Look at this. 986 into 307 minus 986 into 207. Correct? So what is common to both these expressions? You know something called BODMAS rule, right? BODMAS. This is the order in which we do linear equations. Okay, so B stands for brackets. Okay, if there are any brackets, then we have to remove them first. Brackets off. And then division, multiplication, addition, and subtraction. So that is the order in which we do it. So multiplication comes ahead of addition and subtraction. So we have to multiply these first, and then we have to subtract. Okay, don't multiply this, subtract this, and then multiply the result with this. No, that's not the order. First, finish off all the multiplications, and then do the subtraction. So the easier way to do this is, here 986 is common. Correct? So we take that as a common number. 986 into 307 minus 207 is equal to 986 into 100 is equal to 98600. Done. See how much time this would take? 5 seconds tops. Correct? Under 10 seconds, or even in the worst case, under 20 seconds, you can get the answer. Right or wrong? Very simple now. Take the common thing out. The remaining is very simple subtraction. Most of the questions that come in these kinds of examinations have very simple, problem solving. Okay, they don't ask you to multiply or subtract very difficult, numbers and all. If you solve it, you will come into a scenario where the actual problem solving is very, very simple. Get it? So you have to identify, you can take out these things as common, and that is where the technique is what actually matters. In order to get better in that, you have to practice a lot. Okay, otherwise you won't see all these things. Moving on. Another question, 796 into 796 minus 204 into 204, or 796 squared minus 204 squared. You have, sorry, 1 second. Okay, again, you have 1.5 minutes. Please do this. Yeah, Kushbu got the previous one. Very good. Do it and give me the answer, okay? You have 1.5 minutes. Again, think and do. I am giving you plenty of time. Okay, for in your real-time examination, in an examination scenario, you should not take 1.5 minutes to do it. You have to do this in like 20 seconds. Even less than that. Okay. Okay, Nandini is saying 792. Anyone else? 792 is not the answer. It won't be the answer. No, it's a huge, it should be a very bigger number. 592, yeah, almost. You forgot some zeros. Okay, yeah, you got the answer, I know it, but you forgot some zeros. That's it. No, Kushbu got it wrong. All right. So how would we do this? Again, be alert. This can be rewritten as 796 squared minus 204 squared. Right? This is a squared minus b squared. And what is the formula for a square minus b square? Is equal to a plus b into a minus b. This is why I asked you to study the formulas. A plus b into a minus b is equal to a squared minus b squared. So this is equal to 796 plus 204 into 796 minus 204 is equal to 1000 into 592 is equal to 592000. Done. Yeah, that's why I told Nandini almost got it. You forgot that 3 zeros. That's it. See, isn't it simple? You just have to see this. This is a squared minus b squared. If you see that, it's over. Problem is done. The mathematical calculation is very simple. If you look, 796 and 204, and it added to 1000. You know that they put the question in such a way that a person who finds this technique will get the answer very quickly. Okay, had this been a different set of numbers, and if it had added to say 997 or something, then the calculation would be entirely different, right? 997 into 592, that would be a long calculation. The people who put the test won't do it. They know that if the aspirant knows the technique, he should be able to save time in that. So purposefully, they would make the calculations easier. So here it adds to 1000, and multiplying by 1000 is just adding 3 zeros. Get it? So moving on. All right. So now we are going to look into questions based on divisibility. So I hope you remember the divisibility by 3. And what is the technique of divisible by 3? Check whether the digits, the sum of the digits are divisible by 3. That's it. So here is a question. Find the least value of p for which this number is divisible by 3. Okay, here we go. These are the simple questions. In the next class, we will be doing complicated questions. Okay, same idea, but the level of questions would keep on increasing. I'm just trying to make sure that we do all the types of questions so that nothing would be, a surprise for you. From whatever I have taught today, I have only taught you a very little portion regarding numbers, types of numbers, prime number, divisibility test. Based on that, you can do all these questions. Or you have to study those formulas also, otherwise it would take a lengthier time. That's it. If you don't know the formula, it would take you more time to solve it. That's it. You will still be able to solve it, but instead of taking 30 seconds, you would take a minute. That's it. All right, Nandini says it is 2. I will give out the answer very soon. Okay. Last 15 seconds. Anybody else? There are 7 people online. I would request maximum participation and interaction. Doesn't matter if the answer is wrong. Please put it in the live chat. We will discuss it. We will study. Okay. Yep, time's up. So what is the test for divisibility by 3? Check if the sum of digits is divisible by 3 or not. Correct. That is the test. So let's see. 5 plus 9 plus 6 plus 7 plus p plus 1 plus 3. What is this? What is the value of this? 5 plus 9, 14 plus 6, 20 plus 7, 27 plus 1, 28 plus 3, 31 plus p. Okay. So if this number is divisible by 3, then what should be the minimum value of p? That is the question. What is the closest value? P should be a positive number. You can't put a negative symbol. So what is the value of p there? P, if p is say 1, what will happen? If p is 0, let's consider 0. If p is 0, then it would be 31. Is 31 divisible by 3? No. If the value of p is 1, we have 32. So is 32 divisible by 3? No. Value of p is say 2. It would be 33. Is 33 divisible by 3? Yes. So the value of p is 2. Got it? That is how you check for divisibility of 3. Okay, you have to find the least value of p for which this number is divisible by 3. Understood? Because you can actually also put, say, that 31 plus 5. Sorry. Yeah, 5. Here it is 36 and this is divisible by 3. But the question says you have to find the least value of p. That is why 2 is the correct answer. Value of p should be 2. In the UPSC, in the CSAT options, all these options will be given. 2 will be given, 5 will be given in order to confuse you. So make sure that you read each and every word of the question. All right. Next question. I hope you understood. Do anybody want me to explain this once again? No, right? I hope it's clear. Divisibility by 9. Same procedure. Your time starts now. Find the least value of p for which 7p5462 is divisible by 9. Okay, this class would go on for like a bit more than 1 hour. Okay, so like 6:15 or something. But I will take this quickly. Only have like 3 or 4 questions remaining. That's all. But different types. That's it. Okay, only Nandini is giving me answers. Others, please feel free to put your answers in the chat. These are very clear, right? I hope my explanations are okay. Last 5 seconds. Okay, time's up. So how would you check whether a number is divisible by 9 or not? Same procedure, add the digits and see if the sum is divisible by 9 or not. So here it is 7 plus p plus 5 plus 4 plus 6 plus 2. What is the sum? 7 plus 5, 12 plus 4, 16 plus 6, 22 plus 2 is 24 plus p. So this should be divisible by 9. So what is the least value of p so that this is divisible by 9? What is the answer? Value of p should be 3. Correct? So 24 plus 3 is 27, which is perfectly divisible by 9. So the minimum value of p for which this number is divisible by 9 is 3. Very good, Nandini. Got it correct again. Okay, moving on. Tricky. Okay, it's getting trickier. 11. Okay, find the least value of p for which this number is divisible by 11. Again, go. 1.5 minutes, which is probably a bit too much. But again, let's see. After that, I mean, these are very simple questions. These kinds of questions are also very common in CSAT. Okay, you can check the previous year questions and you will see these kinds of questions. And then some a bit more difficult questions that we will be doing very soon. So try to solve this and put the answer in the chat. Okay, this time Khushbu did it faster. Nandini, very good. Again. Yep, time's up. So how would we do this? What is the divisibility test for 11? We have to find the odd number digits and even number digits and find the difference and check whether that is divisible by 11 or if it is equal to 0. Okay, so here, what are the odd digits? 8, P, 3, and 4. So 8 plus P plus 3 plus 4 minus even digits 1, 2, and 8. 1, 2, sorry, 1 plus 2 plus 8. Even digits means not even numbers. I'm saying the numbers in the even places. Okay. So now find the difference. 8 plus 3, 11 plus 4, 15 plus P minus 1 plus 2, 3 plus 8, 11 is equal to 4 plus P. So in order for 4 plus P to be divisible by 11, what should be the minimum value of P? 4 plus 7 equal to 11. And this is divisible by 11, right? So the minimum value of P is 7. Clear? Okay. Now, a typical question that we see getting a bit difficult. What least number must be added to 2010 to obtain a number which is divisible by 19? These kinds of questions will also come in exam, and you would say, sir did not teach us the divisibility test for 19, so we are not going to do this. No. In these kinds of scenarios, just divide. Go ahead and divide. Okay. Divide 2010 using 19 and see the remainder and find out the answer. Plenty of cases will come like this, where you do not have a standard divisibility test that you may remember. So, bang on the methods that you know. Sangeeta, Kushbu, just adjust your uh, what is resolution, screen resolution. That's it. In the YouTube, there is a small, the 3 dots are there in the settings. You can adjust the resolution. Put it into say 480p or above that, and it will be clear. Time's up. So nobody gave me the answer to this one. So how would you do this? There is no standard test. Okay, there is no standard test for divisibility of 9. Maybe there is, but we don't know that. So how do you do this? Very simple. You do the proper division. 2010 divided by 19. What happens? 1 19s are 19. Remaining is 1. And then we put another 1 down. It is not yet divisible. So we add a 0 and put the last 0 also. 110. And so 5 19s are 5 19s are what? 95. Balance is 15. So this is the remainder. So in order for a number to be perfectly divisible, the remainder should be 0. Or a multiple of, remainder should be 0. Correct? So how would we make this into a 19? That is the question. We have to add 4. Correct? If it is 15 plus 4, if this number has been 19, then it will be perfectly divisible. 1 19s are 19 and it is done. Correct, right? So the minimum number that has to be added to 2010 in order to make it divisible by 19 is 4. Just do the proper division, find the remainder, and try to convert that remainder into the divisor. Here remainder is 15 and divisor is 19. So how to convert remainder into divisor? By adding a 4 to it. That's the answer. Clear? Is it? I hope it's very clear. Very simple question. Okay, now we are going to approach some difficult questions. Not difficult, but let's say medium. All right. On dividing a certain number by 342, we get 47 as the remainder. If the same number is divided by 18, what will be the remainder? On dividing a certain number by 342, okay, we get 47 as remainder. So if the same number is divided by 18, then what will be the remainder? Difficult, right? I mean, for now it would seem difficult, but once you understand the concept, it's very simple. Everyone try doing this. It's a very simple question actually, if you know how to do it. You have to find the remainder. Okay, that's all. You don't have to make it into a, don't have to find the number or anything. Just find the remainder. Only a couple more questions. Okay, we will finish like in 10 minutes maximum. Okay, so how would you do this? Anyone? Any idea? Before doing this problem, let me just give you a concept. Okay. How would you do this? 7, okay, divided by 2. Okay, this is not related to this question. I'm just going to give you a concept. 7 divided by 2. So 3 2s are 6 and remainder is 1. No doubts, right? This is correct. So 7 is called dividend. Okay. 3 is known as the quotient. 2 is known as the divisor. And 1 is known as the remainder. I think you all know this. What is a dividend, divisor, remainder, and quotient? Using this, we can actually say that dividend is equal to divisor into quotient plus remainder. Study this. Dividend, okay? So 7 is equal to, divisor is 2 into quotient plus remainder. Correct, right? It fits. So dividend is equal to divisor into quotient plus remainder. You have to have this in your head. This is something that we studied in LP school. Okay, like third grade or fourth grade. I think something like that. Very early in our school days. Probably we don't remember this. All right. So using this method, let's do this question. All right. So let's say that we get the on dividing a certain number by 342, it says that we get 47 as the remainder. Okay, so we have the value of r is equal to 47, and we have the divisor is equal to 342. We don't know the number, so we are going to assume that quotient is equal to, say, q. Okay, let the quotient be q. So what is the number, or what is the dividend? Based on this formula, we can write that number, okay, whatever that number is equal to, what is the divisor? 342 into quotient is q, plus remainder is 47. Correct or wrong? Right or wrong? 342 into q plus 47. Using this formula, dividend is equal to divisor into quotient plus remainder. Now we have to, so this is the number. This is our new number. Now we have to see if this number is divisible. We have to find the value of, we have to find if this number is divisible by 18 or We have to find the remainder when this number is divided by 18. So we are not going to find the exact number or anything. We can't do that with this information. So now we are going to divide this with 18. How do you do that? This is how you do that. Is equal to, okay, we have to factorize into factors of 18. All right. So 342 can be written as 18 into 19. Plus, how can we make 47 into something of 18? 18 into 2, 36 plus 11 is 47. This is how you do it. We have to convert that number in terms of this one, the new divisor, that is here 18. Okay, so we got the number in this formula. Now we are going to convert this number in terms of 18 or in terms of the new divisor. So 18 into 19 cube plus 18 into 2 plus 11. That is this. So this is now perfectly divisible by 18. Correct? Because we have taken that 18 into 19 cube. So we have that whole thing is divisible by 18. 18 into 2. So this is also divisible by 18. So what is the remainder? 11. So the answer to this question is 11. Understood? If you don't know anything, what you do is we have to find the number first. Using the remainder and the quotient and using this formula, we can find the number. Like this, 342 cube plus 47. That is the number. We don't have to find the exact number as such. Just put the number in some form. And then convert that number in terms of the new divisor. Here it is 18. Okay, and whatever we cannot factorize into in terms of 18, that is the remainder. So here 342 cube can be factorized as 18 into 19 cube. So that is perfectly divisible by 18. Then we have 47. In 47, we can split 47 as 36 plus 11. So 36 is divisible by 18. So that is also taken away. Remainder is 11. And that 11 is not divisible. So that is the remainder. Get it? Okay. Another one. What is the unit digit in the product of this long one? Okay, this one I am going to do. Next one you do. Okay. This is another kind of question. You will be asked to find out the unit digit in a given number, in a given, say, equation or something like that. Here, the calculation is 684 into 759 into 413 into 676. So, if you don't know anything, what you do? You will do the entire thing. If you have a calculator, then it is easy. But since you don't have that, multiplying all these things is a waste of time. All you have to do is multiply the last digits. You are asked to find the unit digit. Correct? So, we only need the last digit. So, multiply the last digits. From 684, you have 4. From 759, you have 9. From 413, you have 3. And from 676, you have 6. Correct? And now, what you have to do is multiply these numbers. And when you multiply these 4 numbers, what happens? 4 into 9 into 3 into 6. You have to find out the unit digit in the resulting number. And that is the answer to this question. Clear? So 4 into 9, 36 into 18. Clear? And do this. So we can again simplify this. We can write it as 2 into 18 into 18. So if you know the square of 18, it would be easier for you. So it is 364 and into 2. Okay. So here the last digit, that's all that matters. So 8. 8 is that. So if you are given a lengthy question and if you are asked to find the unit digit, the number that comes in the unit digit place, just multiply the last digits. Okay. And the unit digit in the given and in the answer that you get, that is the unit digit of that number also. Clear? I think that's very simple. That idea is very simple. Don't just forget this question, but just have that idea. And using that idea, do this question. what is the unit digit in the product of 3547 raised to 153 multiplied by 251 raised to 72? Good afternoon, Vishak. Yeah, Seema, very good. Nandini already got the answer, very good. Okay, don't get, if you see these kinds of questions, don't panic. Okay, I used to do that earlier. When I get a question with very high powers and all, how do you do this? Again, the most important part is you have to find the unit digit only. Okay. Last 30 seconds. Anybody? Make sure your videos are not lagging. If it is lagging, just click that live button again so that it will come back to live. Okay, time's up. So how do you do this? When you look at this, it's a very complicated question, okay, with huge powers and all. But how do you do this? Idea is very simple. Okay. In order to do this, you have to, again, you have to find out the unit digit number, correct? So first of all, take the unit digit in both these numbers, 7 and 1. Okay, from here you have 7 and here you have 1. So 1 to the power, whatever it is 1. Correct, 1 to the power 100, 1 to the power, I don't know, a zillion, it is still 1. So that part is safe. So 1 to the power 72 is 1 only. Done, no questions there. Okay, so this is the issue. 7 raised to 153. How do you get that? In order to get that, you have to have some tactics. You have to you have to practice lots and lots of these kinds of questions so that you get it easier. So powers of 7 goes like this. 7 to the power 1 is 7. 7 squared is 49. Okay, 7 cube is 343. 7 to the power 4 is 2041. Okay, this is what we want. Why? Because we want the unit digit to be 1. If it is 1, then power of 1 is 1 only. Whatever that power is, it's still 1. So what do here this is 7 to the power 4. So how do we rewrite this one? We rewrite this as 7 to the power 4. Sorry. One second. My pen is still having some issues. One second. It's not working. Okay, got it. Okay, 7 to the power 4, the whole raised to 38 into 7. We can rewrite this like that. I hope you know that rule. Okay, a raised to m, the whole raised to n is equal to a raised to mn. Okay, so we are actually converting this 153. Okay, that power 153 can be written as 4 into 38 plus 1. That is what we are doing here. Okay, so why are we converting it in the powers of 4? Because we have found a number which ends with 1, and that is 7 to the power 4. So we are converting that whole number in terms of 7 to the power 4. Clear? So 153 can be rewritten as 7 to the power of 4, the whole raised to 38, into 7 to the power 1. Okay, and then you have this 1 raised to 72 also. Okay, so we know that this is, sorry, let me just erase it. One second. Okay, Okay, so we know that this value 2041 to the power 38 into 7 to the power 1 into 1 raised to 72. Because the unit digit is 1, the unit digit of this entire number will also be 1. Right? Then you have 7 to the power 1 into 1 raised to 72 is 1 only. So the final answer is 7. So the unit digit in the product of this big number will be 7 only. Okay, is it, can you understand this? Are you able to get this? Or should I explain this once again, this question? It's a slightly tricky, I know that, but if you want me to explain it again, I will explain it again. Last question, I will come to it, Nandini, 1 second. Should I explain this once again? Yeah, in the last question, you can do that. Okay, Nandini, you can multiply 6 and 8 and you can do it. Okay, moving on. Yeah, Nandini pointed it out correct. I did the whole calculation. You don't have to do even that. You can simply multiply this 6 and 8 and arrive at 48. And 8 is the answer. Okay. Don't worry, we will do more of these questions and it will be very easy for you. So, yeah, only these questions remaining. Here is another one. 200, only one more. After this, only one more question. This one is from the previous class. I wanted to get some corrections. That is why I put it there. That's all. So 264 raised to 102 plus 264 raised to 103. What is the unit digit in this question? Again, use your brains. Don't, I mean, you can't do this anyway. So, I mean, you won't be, you are not going to calculate the whole thing anyway. So, how do you proceed? Remember everything that I have told you up till now and then do it. Last 20 seconds. Okay, let's see how do we do this. Okay, so the first thing that we notice is this is 264, this is also 264, so we can take something common, correct? So how we proceed is 264 to the power 102 plus 264 to the power 103 is equal to 264 to the power 102 into 1 plus 264. Can we write like this? We are taking common. Okay, this we can take common from both these things. So 264 to the power 102 is taken as common. And then what we have remaining here is 1. And here there is 264. Alright, so this is equal to 264 to the power 102 into 265. Correct? Now we have to convert, I mean, unit digit of this is 5, that we all know. We have to find out the unit digit in 264 to the power 102. So how will we do this? You don't have to find the, I mean, we don't have to take the entire number. We only need the unit digit. So unit digit in the four raised to 102. Okay, that's all we need to take into 5. Unit digit of 4 raised to 102 into 5. That's all we have to take. because the question asks for unit digit only. So this is equal to unit digit of, how will we do this? How will we find the unit digit in 4 raised to 102? That is the question. That is the difficult question. So how we do it is 4. Okay, let's write the powers of 4. 4 square is 16. Correct? 4 cubes are 64. 4 raised to 4 is 256. Okay, so we rewrite this thing like this, and 256 is actually divisible by 6. Okay, I will come to that, but we rewrite this as 4 to the power 4 into 25 plus 4 squared into 5. Okay, 102 is being factorized as 4 into 25 plus 2. That is 102. Okay, why did we do this? Because we need 256. So we need a number that is divisible by 6 with that also ends with 6. That's why, because powers of 6 ends with 6. That is a simple reason. Again, you will understand in the next step. This can be rewritten as, what is 4 to the power 4? 256. So the unit digit is 6. So we can rewrite this as 6 to the power 25. Unit digit of 6 to the power 25 plus 4 squared is what? 16. So the unit digit of 16 is 6 into 5. Correct? Sorry, this is not plus, this is into. Okay, sorry. I'm sorry. This is multiplying. Correct? So 6 to the power any number ends with 6. 6 power 1, 6. 6 power 2, 36. 6 power 3, 216. Every time you multiply by 6, it also ends with 6. Okay, so the unit digit of 6 to the power 25 is also 6. So 6 into 6 into 5. So unit digit of this number is 0. 6 into 6, 36. 36 into 5, 180. So unit digit is 0. That is how you find it. Slightly complicated, I know, but just understand, whenever you get these kinds of very huge complicated numbers, try to adjust that number so that the unit digit will become 1 or say 6 or something that is easy for us. Any power of 6 ends with 6. Any power of 1 ends with 1. You have to exploit that. That is what we did here. We have 4 to the power 102 here. Correct? We have to adjust it in such a way that it ends with 6, so that its powers also ends with 6. We could have done with 4 squared instead. 4 squared the whole raised to 50. That's also fine. But this is much more neat, easier. Okay, so this is how you do it. Last question for the day. Find the remainder when 2 to the power 31 is divided by 5. Last two steps not understood. Okay, let's go back. This one, I will erase it and one second. Okay, up to here, did you understand? I hope. You have to find the unit digit in 4 to the power 102 into 5. That up to that you understood, right? So we are going to factorize this 4 to the power 102 in such a way that it either ends with 6 or say 1 or something that is easier for us to calculate. In this case, because it is an even number, we are going for 6. So 4 to the power, we can write 102 as 4 into 25 plus 2. Correct? 102 can be written as 4 into 25 plus 2. This is 102. So a raised to m into n into a raised to p. That is the formula here. All right. And now we are going to find out unit digit of 4 raised to 4 is 256. So it ends with 6. So we can be happy with we can rewrite 4 raised to 4 to the power of 25 as unit digit of 6 to the power 25 into 4 square is 16, and so it ends with 6. So again 6 into last number 5. So this is 6 raised to 25. 6 raised to 25, any power of 6 ends with 6. So the unit digit in 6 to the power 25 is also 6 only. So 6 into 6 into 5. So unit digit of this one, that is 6 into 6 into 5. 6 into 6, 36, 36 into 5, 180. So unit digit of this number is 0. Got it? Now I think you understood. This question, 2 raised to 31 is divided by 5. What is the remainder? Slightly difficult question. Try to do this yourself. Okay, I will do one thing. Now we have already reached 6:30. So you do this and come as a homework or something, and try to come in the next class. I will explain it at that time. Let me just explain this question because I had taken this in the previous class and there was a small error in which in the method I explained it. Okay, so this was a question in CSAT 2021, and the question was, if 3 to the power 2019 is divided by 10, what is the remainder? Which essentially means, what is the unit digit in 3 raised to 2019? That is the question. Clear? So we have to write the powers of 3. In the previous class, I told we have to start from 3 raised to 0. No, that is the error part. You have to start with 3 to the power 1 is equal to 3. 3 squared is equal to 9. 3 cube is equal to 27. 3 to the power 4 is equal to 81. 3 to the power 5 is equal to 243. 3 to the power 6 is equal to what? 9 and 72. Okay, so it goes on like this. If you see this, we have 3971, then again 39, next will be 7, and next will be, and so it repeats again and again. Okay, so this series keeps on repeating. So here the question is 3 raised to 2019. So here we have seen that after every 4 division numbers, it again repeats. So what we do is we divide 2019 by 4. What is the answer? 5 4s are 20. It's gone. 1 0 9. Then 4 4s are 16. Remainder is 3. Right? So the remaining power is 3. So if you look into this, it repeats every 4 times, and we have to check the third time. So 3 to the power 3. That ends with 7. And that is 5. The unit place in 3 raised to 2019 is 7. I hope you understood that. Clear? Just make it into something that is more easily doable for us. That's it. These are, the UPSC will never ask you to find something that is very complicated to calculate. The calculation will be very simple. You just have to identify the technique, the method. That's all. Okay. So that is it for today. Thank you for joining. I know that this class got extended more than I wanted. I was hoping to finish this before 6:15, but we extended by more than 15 minutes. Sorry for that. But I hope everything that I have explained today was clear to you. If you have any queries, please feel free to ask me. The methods to contact me are given in the Telegram channel. The link is given here. Please like this video, subscribe to my channel, and share it with your friends also. All right. So thank you for joining. See you in the next class, which will be on Monday. Okay. Bye-bye.